Okay, let's look at this example and find all the things that they want us to find here. Starting with the roots. Where are the roots of this function? We have roots here, here, and here. In other words, at -4, -1, and 2. Where is our y-intercept? Our y-intercept right here has the coordinates 0 and -2. Do we have local maximums and minimums? We have one local maximum right here at -3, +3, and a local minimum over here at 1, -3. Okay, then let's talk about intervals. Where does this curve increase? It increases in this part and in this part. So our increasing intervals go from -∞ to -3 to the maximum, and we use the symbol for unity for this, remember. And we have another one that starts at the local minimum, +1, and goes all the way to +∞. Where do we have a decreasing interval? There's only really one, right here. And the decreasing interval goes from -3 to 1. And remember, for increasing and decreasing intervals, even though we use interval notation, we never use brackets, because those critical points, -3 and 1, they are kind of between those intervals. They're not part of either one of the intervals. And let's look at our domain. Our domain clearly goes from -∞ to +∞, and actually so does our range. Just for us to keep remembering these different notations, I'm using interval notation for the domain, and now I'm using set notation for the range. There we do have to indicate the y or the x. Use braces, and y is an element of the real numbers. In other words, also from -∞ to +∞. How many turning points do we have? In other words, the turning points are just how many local maximums and minimums, and together that is 2. Let's talk about end behavior. As x goes to -∞, f of x goes to -∞, and as x goes to +∞, f of x goes to +∞. And now we can even go ahead and write an equation. We have so much information already that we can use this to write our equation. F of x is equal to, now let's use our roots, our factors. We get x plus 4 times x plus 1 times x minus 2. All of these roots look like the graph goes straight through them. All of them are single roots. I did leave a little gap here because we still need to find out about the dilation. Remember, A is the dilation, and we still need to find out what that is in order to finalize our equation. How are we going to do that? Well, we are going to use the y-intercept to give us the information to solve for A. If the y-intercept is at 0 and -2, then we're saying where x is 0, y has to be -2 for this function, and we can use those two numbers to plug them into our equation and solve for A. So -2 is equal to a times 0 plus 4, or in other words 4 times 0 plus 1, in other words 1, times 0 minus 2, in other words negative 2. So negative 2 is equal to a times negative 8, negative 8a, and now we're just going to divide both sides of the equation by negative 8, and we are going to get 1/4 is equal to a, and that will now allow us to write down our final equation. F of x is equal to 1/4 or 1/4 x plus 4 times x plus 1 times x minus 2. And double checking again with our end behavior, we have end behavior that goes in the same direction for f of x as it goes for x, and it goes up once, down once. We should have a function with an odd degree and a positive leading coefficient. And guess what we have? Our leading coefficient is positive 1/4, and our degree is 3, which is an odd number. All right, on to the next one. Roots we have at negative 6, negative 2, and positive 3. We can also write x is equal to negative 6, negative 2, positive 3. Our y-intercept is at 0, 3. Let's look for local maximums and minimums. Local maximums first. We have 1 at negative 5 and 2, and 1 at our y-intercept 0, 3. Negative 5, 2, 0, 3, and only one local minimum at negative 2, 0. Increasing intervals are here and here, from negative infinity to negative 5, and from negative 2 to 0. Decreasing intervals, we have 2 as well, and those go from negative 5 to negative 2, and from 0 to positive infinity. Domain and range. Well, our domain is all real numbers yet again, from negative infinity to positive infinity. Our range, however, goes from negative infinity all the way up to positive 3. Positive 3 is our y-intercept and also one of our local maximums. So that is part of our function. That means we need to use brackets here, not just parentheses. How many turning points do we have? We have 3 max and mins together. That means 3 turning points. And now let's talk about end behavior. As x goes to negative infinity, f of x goes to negative infinity, and as x goes to positive infinity, f of x will still go to negative infinity. You can already have some suspicions about what that means for the degree. So let's write our equation. F of x is equal to x plus 6 is our first factor. And if we look back at our graph, we see that the curve goes straight through the x-axis here. So that is a single root. X plus 2 is our next factor. Negative 2 is the place where that curve bounces off the x-axis. So that has to be An even multiplicity of at least 2 means an exponent of 2, and our last root was 3, so x minus 3, and look at how nicely that curve tried to wiggle through the x-axis here. That means an odd multiplicity of 3. And here are our 3 factors. Now our function is not complete because we still need to figure out what A, the dilation is, and we use the y-intercept for that again. So f of x, which is the same as y, is equal to 3 if x is equal to 0. So A times 0 plus 6 is 6, times 0 plus 2 is 2 squared, times 0 minus 3 is negative 3 cubed. And that is a pretty big number, so go ahead and use your calculator for that. I did that myself too. And I get 3 is equal to negative 648a dividing by negative 648. We get negative 1 over 216 is equal to a, and can now go ahead and write our function. F of x is equal to negative 1 over 216 times x plus 6 times x plus 2 squared times x minus 3 cubed. And what do we have? We have a function with even degree. 1 plus 2 plus 3 is 6. And with a negative leading coefficient, even neg means that we would see end behavior that goes down to negative infinity both times. And that's exactly what we found. Alright guys, great job. This is it for this lesson, and I will see you in class.